Hello everyone, welcome back to my YouTube channel. Let's tackle this new question. Let's read the question first. A particle of mass m is thrown with initial speed u at an angle alpha with horizontal. If the maximum height reached is much smaller than the radius of the earth, then calculate the angular momentum of the particle about the point of projection after time t. Let's just write what is given in the question in the figure form. Solution. Let's define our axis first. X-axis, y-axis. Particle is thrown like this. Let it make an angle alpha with horizontal with initial speed u. A particle of mass m is thrown with initial speed u, making an alpha with horizontal. If the maximum speed, if the maximum height reached is much smaller, let this be the maximum height. Wait a minute. This be maximum height reached is h. Calculate. There are two methods to tackle this problem. Let's look at the first method. Just write what are all given in the vector form. Let's first write the position code, position vector for any random point on this projectile. Let's define this like this. This is r for any random point x comma y. Now we can write r is equal to x I cap plus y j cap. Now let's resolve this u into two components, namely along the x direction and y direction. Those will become u cos alpha and u sin alpha. So vector u is given by u cos alpha into I cap plus u sin alpha into j cap. Now by equations of motion we have s is equal to, the distance is equal to ut plus half at square. Remember, these are the equations of motion in a straight line. When the axes are considered separately, this will work. Otherwise it won't work in a two-dimensional plane. Like I'll explain this to you now. X, how can we write x now? Just take x component here into t plus half into take component of the acceleration here into t square. So this is how it works. Now let's clean this up. So we'll end up with a clean board now. What is the value of x? X is equal to ux into t plus half x t square. Remember, the gravity acts downwards here like this, mg. Let's be clear, this is method 1. X is equal to xt plus half xt square. This term is 0 since there is no acceleration along the x direction. So a is equal to ux means u cos alpha, right? U cos alpha into t, and y is equal to the similar formula, yt plus half ay t square. Y is equal to uy means u sin alpha into t minus g t square. because the acceleration is acting downwards, hence the minus sign. Now r is equal to x means u cos alpha t I cap plus u sin alpha t. Remember, the sin alpha is one term and t is into t. Sin alpha whole into t minus half gt square j cap. When we differentiate this, like this, when we differentiate this, we get velocity as a function of time. Remember, this is the function of time, position vector as a function of time. If we put time from 0 to the time of flight, we get all these points on the curve. So dr by dt is equal to velocity at any instant is equal to, let's differentiate this equation, the above equation, u cos alpha I cap plus u sin alpha minus gt into j cap. We have to find angular momentum about the point of projection after time t. After time t, let the particle be at this point. So we have to find angular momentum. It's pretty clear in the question. So angular momentum, for angular momentum we have to first find momentum. P is equal to m into v. It implies m into u cos alpha into I cap plus u sin alpha minus gt into j cap. So angular momentum is defined as r cross p. This means r is u cos alpha t into I cap plus u sin alpha t minus half gt square into k cap cross m into u cos alpha I cap plus u sin alpha minus gt into j cap. Oh, I stand correct here. This is not k cap, this is j cap. Solve this. Just take the determinant. I cap, j cap, k cap. The component of x in r is u cos alpha t. Y component is sin alpha t minus half gt square, and z component 0. Z components are both 0, and here the m gets outside. U cos alpha, u sin alpha minus gt. So this becomes, L becomes m into I cap. This into this is 0 and this into this is 0. So I cap into 0. Let's erase this. We do want to get our notes dirty. Minus j into by deleting these rows and these columns, we'll multiply this into this and this into 0, so we'll end up with 0. So there is no point in writing that to j cap into 0. Now here comes the final answer, plus k cap into this into this. So what we get, u cos alpha t into u sin alpha minus gt minus u cos alpha into u sin alpha into t minus half gt square. So L is equal to first we'll write m into k cap into, let's solve this. U cos alpha t into u sin alpha is equal to u square sin alpha cos alpha t minus u cos alpha into g into t square minus u cos alpha into sin alpha, u becomes u square into t minus u cos alpha becomes half here minus half into u into cos alpha into g into t square. This term and this term gets cancelled out, so m into k cap into minus u, let's write ug, so it looks beautiful, ug cos alpha t square minus ug cos alpha t square by 2. This becomes plus here, this becomes plus, so what we have, L is equal to m into k cap into minus ug cos alpha t square by 2, or write this like this, L is equal to m g u cos alpha t square by 2 into minus k cap. This seems good. Okay, let's decorate it now. Oh, sorry. Okay. So now let's look at another method to solve this problem. Method 2. Let's define our axis first. Here is the projectile, here is initial velocity u, angle alpha. Okay, this is pretty much it. This is maximum height. So at any point here, x comma y, this is the x coordinate, right? So we'll solve this problem by the torque method. We know that torque is perpendicular distance from the point about which we are willing to find the torque into force. This is just a magnitude. If you write in the vector form, we'll have r cross f. So tau is equal to the perpendicular distance is clearly x and f is here mg. In vector form, tau is equal to r cross f. This means x into mg into minus k cap. How did I write minus k cap? This is the whole new another chapter. Just I'll explain it to you shortly. We have r like this and g like this. So by right hand thumb rule, if you curl your fingers along this direction, then you will have the thumb pointing the direction away from the screen like this. This is towards the screen, this is away from the screen, so that is minus k cap. I hope you get it. Otherwise, see any video on the YouTube, you'll get to know. So we now have tau is equal to xmg minus k cap. So x, we already know that x is equal to u cos alpha into t into mg into minus k cap. Okay, now we know we again know that tau is defined as rate of change of momentum. As in Newtonian mechanics, we know momentum is the force is defined as rate of change of momentum. Similarly, we have the torque is defined as the rate of change of angular momentum is equal to u into mg into cos alpha t minus k cap dl is equal to u mg cos alpha minus k cap into t into dt. Now integrate it like this from the limits 0 to any arbitrary L. Remember, L is the angular momentum, from time 0 to any arbitrary time t. So L is equal to u mg cos alpha into minus k cap into this becomes t square. Let's make this right, divided by 2. Let's write this sign. Let's make this beautiful. L is equal to m g u cos alpha t square by 2 into minus k cap. So this is pretty much it. I hope you guys like the video. If you like the video, hit or share with your friends, like it and subscribe. Thank you. We'll meet you in the next video.